Okay guys, so I have been working on a line follower robot for past few days for the upcoming technician competition, and I was thinking of making my own sensor, the line sensor actually. So for past few competitions I have been using the Robo Junkie sensor, these ones. I have 5, 7, 8. I have used all three of them, and don't get me wrong, they are all quite good and quite capable, but I was thinking to make my own sensor for obvious reasons. The cost is one of them. So while looking at the sensor, I found out that the components that they use are more or less similar to the Pololu one. So if you see Pololu QTR sensors, so this one is QTR8RC, but the RoboJunkies ones are analog sensors. This is charge transfer resistance type. So right here you can see this photodiodes are similar to RoboJunkies one. Now I was thinking that if these are available, why can't we make our own? So as anyone would do, first of all I read few of these documentations, and after that I found out that the sensor is QRE1113. Well, in Robo it is available of spark fun, but it's quite costly. So like like first of all I read the data sheet, then I just checked Robo, and in checking datasheet we can find out that there are two versions. One is 1113, which is through hole. Another one is GR, which is SMD type. So yeah, we got the component, we got the pinouts. Now one thing I noticed, which is actually quite helpful, this breakout board is analog type. Okay, so it does not use an RC circuit, instead it is analog. So when I went to attachment and I saw schematic, so this is the schematic which was given. So now this is open source in the Creative Commons. So if this is present, we can take reference from this and design our own circuit. So actually the basic of the circuit is we have a IR transmitter which transmits data, infrared light, and IR receiver which receives light and gives outputs on one of its terminal. This whole thing, the QRE1113, is done in a single package, so it takes quite a less space. So now I think we got the overall idea how this works, so we can try to design. So first of all I will open EasyEDA. I generally use KiCad also, but for this I'll use EasyEDA. Now let's fire up a new project. Name this QRE. I'll make 8 channel, 8 channel analog. Okay. So you can see here there are basically 3 components, 2 resistors and 1 main photodiode. So now let's observe. The R1 is connected one end to VCC and one end to, I think, what pin was this? Pin 1. Okay, so pin 1, and another pin 2 is connected to ground. And now the pin 3, I suppose, yeah, pin 3 is connected to VCC through a 10k resistor, and the pin 3 gives the output, and then the pin 4 is connected to ground. So what actually happens is that the more the light is reflected and it is received, the more current accumulates here. So like proportionally voltage rises. That is basic theory. So this gives the output, and this is obviously current limiting resistors. So first of all, now I will search for QRE1113GR. Let's see. Oh sorry, it's 113. I'll search for 113. Yeah, we got manufacturer on semi, and this is also on semi. Okay, so this same. I'll place this thing. Okay, so now we have got our photodiode, and now I will have to add the current limiting resistors. So since the sensor size will be small and we will generally use reflow process, we won't use hot air because the case is made of plastic and will melt. So we will either use hot plate or oven reflow or whatever. I'll use a small size resistor, say 0603 or 0402. 0402 will be very small, so I'll go with 0603. Now it was connected to pin 1 and pin 3, right? Let's check. Pin 1 and pin 3. So it was 100 and it was 10k. And now these two are sent to VCC. So I will just use a regular 5V net. Okay, same. And these two was directly tied to ground, so I will use ground to connect them. No issues. And now at this point between resistor and pin 3, it was giving output, so I will just use a net to connect here. Let's say in the net to, let's say, A0. This is basically the output of this sensor. So this setup is complete for one sensor. Now we will have to repeat the same for all the 8 sensors. Actually, I'm going to delete this. I will put it at the last. So I'll just simply copy and paste for 8 times. Okay. So now all the 8 setups are complete. Now I will simply use output levels. This is, oh, it's coming as even, so I will use here A1, A2, A3, A4, A5, A6, A7. Okay, and the first one is left, so I will set this to A0. Okay, now all the setups are complete. Now we'll have to add a connection to get our sensor connected to our microcontroller. So we'll use common male headers, so or 8 analog outputs plus 2 power, so it will look 10. is here. Let's say interview A1, A2, A3, A4, A5, A6, A7, and here A0. Let's move it a bit, and one will be for VCC, which I use 5 volt net, and one is ground. So let's add a decoupling capacitor. So there is 0603. So let's add 2. To filter out frequencies, generally it is like 0.1 microfarad and one is 100 picofarad and one is 100 nanofarad, which is 100 microfarad. It's alright. So this same, and okay, our schematic is completed. Change name. Okay, so we'll save this and we'll convert it into PCB. I don't want, I'll make my own. Let's say this board outline. So one thing I would like to tell you, since there was no error or unconnected nets or anything, hence the design manager did not give any error. Like if I disconnect a ground and save and then click on here, now when I try to convert into PCB, it will ask to check nets or do you want to keep them. Now if I check net here, it says incomplete net, so one of the pins is not connected. These are all okay, the pin descriptions. So I won't do anything, I'll just keep this as same. I'll continue with my PCB. So one thing to notice here is that our PCB will either be a rectangular one, all sensors in same line. We can do like a slide band like this with sensors slightly shifted upwards, which helps in intersections. So I think we'll keep the outline rectangle and we'll shift the sensors up and down. That's no issue. But the main thing here is sensor will be in the bottom layer. So when you look from under, the sensors are there, and the connection are multi-layered. The jumper wings, the male headers, so it does not matter anyways. So we'll have to, and all the resistors and capacitors will also be in the bottom layer, so we'll have to change them to bottom layer. So I'll remove this and here bottom layer. Okay, so all this has changed to bottom layers. I'll use bottom layer. So U1 has, let's check, U1 has R1, R2, U2, R3, R4. Okay, same. U1 has R2, where is R1? Yeah, R1. U2 has R3, R4. U3 has R5, R6. U4 Similarly 5, 6, 7 and 8. 6 is done. 7, 8, 9, 10, 11, 12. Same here, and we are done. So now we will arrange. First of all, let's align all these sensors. This is align, yeah. And we'll see position of the sensor, so we can equally place. I use unit in millimeters. So that's the position. 10 mm. This one 20, 30, 40, 50, 60, 70, 80. Actually the position also matters quite much. Like if you have two larger gaps, then the line will not be accurate, and if you have two narrow gaps, then many sensors will be under the same line, so you will have to increase the number of sensors. So I think 0.8 to 1 mm is good choice. I have read in Pololu documentation, I guess, if I'm not wrong. Just a minute. Well, I'm not finding it. Whatever. Let's continue. So 0.8 to 10 mm is alright. Like 8 to 10 mm. Sorry. Now if I measure from here to here, and the pitch, you can see the pitch is 10 mm. So each sensor, for each sensor the pitch is always 10 mm. Your pitch is actually the midpoint from one to another sensor, or pad or pin, whatever you say. That is the pitch. For example, like in this nail header, the pitch will be 2.54 mm. That's a standard nail header pitch. Okay. So now we'll see. This pin is connected to here, and this is file, so we'll rotate for easy connection. Well, before that, let's actually shift the sensors up and down. This will be right here. This one, let's say it was 38.1, so we'll do 39.1. This one, let's do 40.1. This one 41.1. It's kinda bent, but it's alright. I will simply rotate and place the components for easier connections. I'll align each one. This is going to take a little time. Okay, so almost all the components are placed. Now it is looking kind of ugly, so what we can do is we just off all the prefixes. Now it's looking good. So what we can do when soldering is that we can usually check our PCB design and place the resistors accordingly. Now let's mark all the pin. I don't like this square one actually. It's good. Yeah. So it will be, let's make top silk clear, right? So let's change the size. So this good. 0.8. Okay, nice good. Make it and this is it. Okay, let's do the pin numbers. 0, 1, 2, 4, 6, 8, 7. So we can try to align it. Yeah, that's good. Now we can actually move it a little bit upwards. Yeah, that's good. So now let's make our board outline. We'll use wire tool. Let's get this 80 will be good over here. 80 and this one, let's say 20 okay, 20 is too good. 15 will be good. Yeah, 15 is good. Same here, we can do 15. Let's do 8. 8 is the capacitor, so going out. Let's put them inside. So this is the, so you see the image, this top side, this bottom side. You can see this strokes are quite on top. You can possibly bring them down a little bit. We'll do that. By doing this, we can also like reduce the size a little bit. So in line follow, every gram matters. Like the lighter your watt, the more you will chance of using. Well, basically it is how you make your watt, but yeah, it still counts. So that's the answer. Now let's route it. You can either use auto route or we can route it manually. I'll use auto route, it's simpler. Okay, so the routing is complete, and yeah, I think the functional requirements is fulfilled. You can see it's looking quite good. Now if I change color to say black, yeah, it works. Blue, green. Okay, so let's tweak some more. Let's say we want to add holes, alright, like what you can do is you can create an extension right here and you create a hole, but I think I will do it right here, so I will unroute it out, use the hole tool. I use first hole diameter, I'll set to 3.031, and 35. Yeah, so this is one hole, and I'll just copy it. Let's say it's 35, 10. Actually 50 mm cap, actually 25 plus 50 is 75. My bad. Okay, so it's getting uneven. I can reduce it. So 65. Yeah, this works. So there will be 25. This one is, this hole is 65. Right. 65 minus 25 will be 40 mm. And check. Yeah, 4132. Yeah, it's 40 mm. And y is also length. Okay, it's alright. Route. Okay, so the routing is done. This one is top. It may cause issues, so I'll route this one manually. Okay, so this factor should be connected, or from here to here. I'll just put a wire in this pad, and I'll use top level. Yeah, this is done. Like your track should not be too close to the board outline, it should be a little bit inside. This one is too close to the hole. Yeah, it's okay. So now let's add some seal. First of all, we can use some markings for sensor. Like I use a star symbol just to mark the position of sensor. Really convenient. say to mark the center, I'll use right here. It will be instead I can use this symbol, rotate, and yeah, so marks the center. Let's hit some save. Well, we'll use our name, QRE1113. Say sensor QRE1113. Open and rotating, press it right, align this. It's good, I think. That's in 3D. Yeah, it's good. The sensor placement in the center, and yeah, everything looks great. So this is how actually how you can design your own sensor instead of purchasing them. I was thinking of using TCRT 5000, but that will increase the weight of my pot a little bit, so I won't be using that right now. We have actually secured line following competition first position 2 times in IIT Patna, 2023 and 2024, and this time 2025 in Cognizance IIT Roorkee. We were using one was wave shear, yeah, wave shear line sensor. Well, this is also quite good sensor, this one, yeah. This also gives good output. It is highly reliable, but the thing is it gives inverted output. So like if this QTR gives output 1 on black, it will give 1 on white. So you can adjust that in code. Yeah, it was also a good sensor. And Robo Junkies was one of the main sensors that we were using, the 8 channel one especially. So this is how you can make your own sensor or any other circuits which you want, like to make your own thing. Yeah, so this is all. And I was actually working on 16 channel analog sensor, and I was trying to use Atmega 256 here without multiplexer for 16 channel sensor, but that will be for future videos. So if you like the video, share as much as you can. Thank you.